All right, now we're doing 10.3 video, section 10.3. This is trig in the coordinate plane. It's a touch more difficult here. All right, state the number of degrees in each of the following: a complete circle. Well, hopefully everyone knows that that is a 360-degree circle. Well, 1/4 of a circle is going to be 360 divided by 4, which is 90, right? We know that. If we look at a quadrant, we know that a full circle is 360, and 1/4 would be 90. Half a circle is 2 times the 90, so it's 180. I'm going to put degrees on there. 3/4 of a circle, so that's 1, 2, 3/4, so that's 270, or 3 times 90. 2 complete circles. Well, let's see. I'm going to change my color here. And I go 1, 2. Well, it's 2 times 360, which is going to give me 720 degrees. When an angle is in standard position means that its initial side is along the x-axis, so you can see that here, and that its terminal side is the one that's swinging free. Okay, so that's this side here is your terminal side. This is referred to as a sweep, and you will always show your sweep or you will not get credit. The thing is, a sweep tells me which direction you're considering this as going. Because I could also have, see this negative 200? It could be sweeping that direction. So without a sweep, I don't know which one it is. All right, 2 angles in standard position have the same terminal side. Terminal. Let's see. You terminate something. You end it. You arrive at the bus terminal. You end your trip. Terminal means to end something. So the terminal side is the ending of your angle. So 2 angles in standard position that have the same terminal side are called coterminal. So as you see in this case here, negative 200 is coterminal with the 160. They both have the same terminal side. Okay. Now, I could find that value if I did 160 minus 360, a full circle, I would get negative 200. Okay, so that's how you're going to find your coterminal angles. Okay, given theta is 210, draw the angle in standard position. There you have it. It's already done for you. Okay, 210. I know that this to right there is 180. I need an additional 30 to make this 210. Okay. Given theta equals 210 degrees, identify a positive and a negative coterminal angle. Okay, to be coterminal, for my negative, I subtract 360, and I'd get this angle, which is negative 150. Right? Oh, that was terrible. The degree didn't even meet. There you go. Okay, to find a coterminal positive, I would need to go around a full circle and then on to here. So that's why I have to add 360. So I'm going to get 570 would be my positive coterminal angle. Sketch these out. It will help. Okay, given 210, write an expression representing all its coterminal angles. Well, I know that I have to add, but I can add 2 circles, right? So I could do 1, that was 1 extra circle, 2 extra circles, and then here. Or I could add 3 extra circles and 4 extra circles. And I can add as many as I want. So what this turns into, 210 degrees plus N360. To find the negative coterminal, it's the same, 210 minus N360. But if we state that N can be negative, we can make it just the general term right there, okay? That's your standard form of how to find coterminal angles. Coterminal angles are very important. Okay. Now we're looking at number 7. Slide 7. Given the point xy on the terminal side of an angle in standard position, r, which is our distance to the origin, is found by doing the square root of x squared plus y squared. Okay, I think, let me do a real quick bit of it there. Okay, so what we're saying here is, let's say I have a terminal side here. I have this point on it. It's going to have an x and a y value. Now I can find this distance out by doing Pythagorean theorem, right? Because this side would be y tall, this side would be x tall. So using the Pythagorean theorem, I have x squared plus y squared equals r squared. So r is the square root of x squared plus y squared. Now, this is our SOHCAHTOA, only when you have a point, we call it circumference. That's what you see right here. Circumference. Okay, so my sine is y over r, my cosine is x over r, and my tangent is the y over x. Okay, because basically what we're doing is finding this angle right here. It's the it's actually called a reference angle, but it will give you the proper values. Now remember, with the x and y, you want to maintain the negative. In this case, my x is going to be negative. So this would be negative, and this one would be negative, this would be negative, and this would be negative, because the x is negative. Sine and cosecant would be positive because the y is positive. Look. Yeah, you get a... All right, now example 2. State the 6 trigonometric ratios of angle theta in standard position. This is theta. Our angle is this outside circle, this outside sweep. But we can still use this point. So what this is going to do, and again, we're doing circumference. So r is 5 squared plus 12 squared. Well, that's going to be 13. So my r is 13. So now that I have that, sine is y over r. My y is 12, negative 12. My x is 5. So if sine is y over r, I have negative 12 over 13. If cosine is x over r, I have 5 over 13. Tan is y over x, so I have negative 12 over 5. And now I just flip these for the other term. So cosecant's going to be negative 13 over 12. Secant is 13 over 5. And cotangent is negative 5 over 12. Okay, so that's all my values. All right, now we're going to talk about a quadrantal angle. A quadrantal angle is an angle whose terminal side is on an axis. In other words, it's a full quadrant. Quadrantal angles are quadrants. Okay, so we have 90 degrees of quadrantal angle, All right, we have 90 degrees as a quadrantal angle. We have 180 degrees. We have 270 degrees. And we have 360. Notice that 360 is also 0. It can be expressed either way. Okay. So, example 3. State the 6 trig ratios of 180. Well, we're going to use cirkix or ticks again. So, what is our y and our x? We select a point on the terminal side, -2, 0. Okay? We're going to go out here and select that -2, 0. This is our angle. So, our x is -2, our y is 0, our r is 2 because r is the square root of 2 squared plus 0 squared, which is the square root of 2 squared, or 2. So r is 2. Now I can just do cirkix or ticks. Sine is y over r. Well, 0 over 2 is 0. It is, cosine is x over r, minus 2 over 2. Well, that's -1. Tan is y over x. 0 over -2 is also 0. Now we have a problem. When we come to these reciprocal functions, if the value is 0, when I do the reciprocal, it's undefined. So cosecant is 1 over 0. So that is undefined. -1 over -1 is again -1. And again, I have 1 over 0, so this is also undefined. Okay, so we have to be careful of these when you have a 0. All right, any non-quadrantal angle theta has an associated reference angle. Tried to give you some examples. It's the angle that moves to or sweeps to the x-axis, not any axis, the x-axis. So notice that in the first quadrant, the reference angle is the same as the original angle. In the second quadrant, notice that it's still making the angle with the x-axis, so it's going to be 180 minus the given angle. So if the given angle was 130, it's going to be, the reference angle is 180 minus 130. This is an important concept. Okay, on the third quadrant, again, notice I'm going to the x-axis. So my reference angle for 225 is going to be 45 degrees. Now, one of the things I draw out for my students, wow, I pressed too hard. Reference angle makes a butterfly. See, if I have an angle here or there or there or there, the reference angle, notice it's making a butterfly. Okay, let's do it in different colors, so you can see the pretty butterfly. Okay, so see, I've got a butterfly. Remember that shape, it's important. The reference angle is to the x-axis only. Only, no y-axis, only x. All right. State the exact values of the 3 basic trig ratios for 210. Well, notice 210 gives me a 30-degree reference angle. With a 30-degree reference angle, I know my side ratios. I have 1, √3, and 2. Now, because it's in this quadrant, the x and the y are both negative. So that's why I have these negative values, is because this angle is in the third quadrant. All right, now, to state these different values, I know that for a 30-degree angle, the sine is opposite over hypotenuse, so it's going to be -1 over 2, -1/2. For the cosine, is adjacent, so it's going to be -√3, again, over 2. This tangent, though, is both of them are negative, right? Both side lengths, negative root 3 and 1, are negative. So it's going to turn out to be positive. So it's opposite over the adjacent. So therefore, rationalize its root 3 over 3. All right, now example 4b. State the exact values of the three basic trig ratios for negative 225. Here we have it drawn out. This will always be important for you to remember. All right, so we're basing it on this quadrant. So, being a 45, I know my side lengths, my legs are 1 and 1. I know my hypotenuse is root 2. So, I also know, since it's in quadrant 2, that the x value is negative, so it's negative 1. So sine is opposite over hypotenuse. Opposite over hypotenuse. I rationalize, and I get that. Cosine is adjacent over. So this is now negative 1 over root 2, which is going to give me negative root 2 over 2 when I rationalize. Tangent is opposite over adjacent. Opposite over adjacent. So I'm just at negative 1. All right, so that's how we work out these values. All right, and there we are. All right.